This is exercise 5 from 7.3. This is going to be F. F here has the audacity to show us 3 inequalities, or 3 sets of inequalities. This one's actually got 2 inequalities in it, and it looks really complicated. But we're going to find a way to put it onto a graph and find out which areas are common to all 3 of these conditions in this linear system. So I've rewritten them all here. I'm going to color code them as well. Let's call this one the blue one. X minus y is greater than or equal to 1. And this one will be the pink one. And the pink one, x minus y is less than or equal to 3. And, well, I'm out of color, so we'll just call this one the black one. The black one says that negative 1 is less than or equal to x, which is less than or equal to 3. In other words, x is between negative 1 and 3. So that's going to be the easiest one for me to graph, and I'm going to graph that right away. Negative 1 is less than or equal to x. Well, less than or equal to, solid line. Less than or equal to, solid line. So, where is x equals negative 1? That's this here. And I'll just bring out my trusty straight edge here. Can't afford a real ruler. There we go. So that line right there, that line is x equals negative 1. So if x is greater than or equal to negative 1, then it must be on the right half of the plane over there. So it's going to be on this side. Then this part here says x is less than or equal to 3. Well, 3 is here. And so we'll draw that as well. That line is the line x equals 3. And so in between these two is where x can fall. And if that were all there was to it, I would shade that column of space in, and everywhere in between these two lines, and including these lines, would fit the solution of this particular inequality. But I've got more to do. I've got to put on the pink line and the blue line. So the blue line, let's take this blue line over here. We're going to turn it into slope-intercept format. So I'm going to just take it and I'm going to add y to both sides. So I've got x is greater than or equal to y plus 1. And then I'm going to subtract 1 from each side, and I get x minus 1 is greater than or equal to y. Now I can take this whole thing and flip it around. If x plus 1 is greater than or equal to y, then y must be less than or equal to that stuff. So I could do it this way. I could write it that way. That's just a mirror image of it. Remember that this is pointing at the y, and here it is pointing at the y too, so it's really just the same thing. And this is a more familiar look, the more familiar slope-intercept format. So the slope here is 1, or 1 times x, and the intercept here is negative 1. So graphing is quite straightforward. The intercept is here at negative 1, and the slope of 1 means up 1 over 1, up 1 over 1. So it's a 45-degree angle, which I can just draw in like this. I'm just double checking it is greater than or equal to, so I can use a solid line. And there it is. So that is the line y equals x minus 1. So I'm just keeping that in mind. The inequality will either be on the upper side or the lower side of that. We'll worry about that stuff later. Let's go over to the pink one. The pink equation, when I put it into y-intercept form, I will, let's see, I'll take the y and add it to both sides. That leaves me with x is less than or equal to y plus 3. And then I'll subtract 3 from both sides. I get x minus 3 is less than or equal to y. And it's pointing at this x stuff here, so I can rewrite it like this. Keep pointing at that stuff. That's the format I like. I'm more comfortable with that. And once again, it's a slope of 1. That's 1 times x. And the y-intercept is minus 3. So I'll just go down to minus 3 here. That's the y-intercept. And wouldn't you know it, a slope of 1 means that it's actually parallel to this other line. It's got the exact same slope. It's just 2 down. So it's got to be parallel. slope of 1. Hopefully it looks, there we go. So this one is y equals x minus 3. This is just the equation of the line, and that's why I'm putting the equal sign in here. So now it's time to do some shading, and we have to decide what to shade. Now we know that for this black one here, x is between minus 1 and 3, so it's going to be the inside of these two lines. For the pink one, y is greater than that stuff, so it's going to be the upper half. The upper half, or up higher than the line. And for the blue one, y is less than that stuff, so we know it's below the blue line. So the only space that meets all those criteria is this little space in here. And any point in that little space right there will, if substituted in for the x and y in all of these, will make all of them true. And only the ones in this little space.